All right, we're in section 10.5 where we are going to find probabilities of independent and dependent events. Anytime we are looking at independent and independent events, we're looking at and statements of different probabilities. And statements simply mean that we are looking at uh, more than one occurrence or more than one piece of data that we're trying to find. Like what's the probability of this and that happening? And the question we have to ask ourselves is, are they independent, which means they have no effect on each other, or there is a dependent, which there is an effect, and you have to make that conclusion. So when the probability of an and statement is independent, you're simply just multiplying those two pieces of probability together to get a results, to get a probability of those two events. All right. Depending on how many events there are, stuff like that, you may have to multiply more terms, kind of like what you have to do here. So it says that every morning one student in a class of 24 is randomly chosen to take attendance. What is the probability that the same student will be chosen 3 days in a row? All right, so this is a situation where we have an independent event. Okay, there's nothing that occurs in the first event that's going to make the second or third event even that any more likely or any less likely. So essentially it's just going to be the probability. All right, so we have to find the probability of A occurring times by the probability of B occurring times by the probability of C. So the first thing is on the first day, the probability that one student being chosen to take attendance is 1 out of 24. Same thing goes for the second day, 1 out of 24, and the third day, 1 out of 24. So since they are independent events, we multiply them. So 1 times 1 times 1 is 1, and then 24 times 24 times 24 is 13,824, which if you tried to tag that as a percentage, it's a very small percentage. If I just wrote it as a decimal, I think it's like 0.0000723. Okay, so less than 1% chance for sure. Okay, here it says that a manufacturer has found out that 2 out of every 500 coffee pots produced are defective. What is the probability that at least one coffee pot is defective in the first 300 coffee pots made? So here it says the probability of not making a defective coffee pot is what? So in the grand scheme of things, it says that 2 out of every 500. So of not making a defective one, that's going to be 498 out of 500, which that equals what, 0.996, which if you tagged it as a percentage is about 99.6%. So there's a 99.6% chance if you chose out of 500 of them, you would get a non-defective coffee pot. So here it says each coffee pot made is an independent event. So the probability of making at least one defective coffee pot is going to be, now we're going to kind of almost use like the complement from the previous lesson. It's going to be 1 minus the probability of making a non-defective coffee pot. But they said that to make one that's at least one is out of 300. So what we're going to do is we're going to tag this and raise it to the 300 power. All right, so here it's going to be 1 minus, and we just said that it was a 0.996 chance that it's not going to be defective. But what we're going to do is we're going to take that 0.996 and raise it to the 300 power because we have 300 coffee pots that we're trying to look at. So 0.996, raise that to the 300th power, I get like zero point 0.3. So 1 minus zero point 0.3, that gets us 0.7. So there is a 70% chance of at least one of the coffee pots to be defective. All right. Here it says during a high school track meet, each race consists of 9 competitors who are randomly assigned lanes from 1 to 9. What is the probability that a runner will draw lanes 1, 2, or 3 in the 3 races in which he competes? So this is another situation where they're all independent events. There's nothing that carries over from the first event into the second or even into the third. So the probability of you being in lanes 1, 2, and 3 are 3 of 9. Same thing goes for the second race. The same thing goes for the third race. So 3 times 3 times 3 equals 27. 9 times 9 times 9 equals 729. Is that in lowest terms? No, it can be reduced to what? 1 over 27. And that is about 0.037, which is like what? 3.7%. Okay. And this problem here is kind of like the coffee pot uh, question up above. It says a manufacturer has found that 6 out of every 450 batteries produced is defective. What is the probability that at least one battery is defective in the first 100 produced? So the question that you first have to ask is uh, what is the probability that it's not defective? So in this case, you would have 444 out of 450, which if you wrote that as a decimal, it would be 0.987. So to figure out how many if you to get at least one battery defective in the first 100, it's going to be 1 minus the probability that it's not defective. In this case, it's 0.987, and you're going to raise that to the 100th power because you're trying to figure out the first 100. So 0.987, raise it to the 100 power is 1 minus 0.27. So I got 1 minus 0.27, so that I get about 0.73 or 73% chance of at least one being defective in the uh, first 100 produced. All right, so now we're going to look at dependent events. All right, so dependent events mean that it's the probability that both A and B occur, and what it means is you have the probability of A times it by the probability of B given A. So when you have probability of B and A, this notation is a conditional statement saying that A was already made up to be true. So since that was true, what's going to happen with B? All right. Usually, what happens in these types of situations, it means like you didn't replace something or something to that matter, and that's why the probability or whatever the situation changes a bit for that second fraction or that second piece of probability. So here we have a diagram. It says male and female with different colored eyes. So here it says use the chart above to find the probability that um, a listed person has blue eyes. So there are So there's 35 plus 9, so that's what, 44. So 44 people have blue eyes out of, let's see here, 27, 12, 35, 9, 15, 38, 23, 41. That's 200. So reduce that, that's about what, 0.22 or 22%. Okay. All right. Here it says males that have blue eyes. So males that have blue eyes in this case are 35 over 100, which is going to be what, 30.35 or 35%. Here we have C, talking about hazel, female hazel eyes. So there were 41 females with hazel eyes, and there were 100 total females. So that's 0.41 or 41%. Okay. All right. So looking at these problems here, one problem is going to be dealing with an independent event. The next one's going to be with a dependent event. So it says that you randomly select two marbles from a bag containing 15 yellow, 10 red, and 12 blue marbles. What is the probability that the first marble is yellow and the second marble is not yellow if you replace the first marble before selecting the next marble? When you replace the first marble before you select the second marble, the two events are independent. So by putting that marble back in there, it's an independent event. So since it's an independent event, they want to find the probability of a yellow and times it by the probability that it's not yellow. And the little squiggly mark means not. So we have, there's 15 yellows, and you have 15 out of 37 chance, and it gets multiplied. So the ones that are not yellow, you add them together, that would make it what, 22? So 22 out of 37. So the probability, 15 times 22 is 330. And then 37 times 37 is 1369. So that is what 0.241 or about 24.1%. Here it says you do not replace the first marble before selecting the next one. So keeping the same idea, probability of getting yellow for the first one is still 15 out of 37. But when you multiply this one, it's going to be 22 out of 36 because you have one less marble because it did not get replaced. So on the top, it's still going to be 330, but on the bottom, we got 1332, which gets us 0.248, which is about 24.8%. All right, so here we have, it says find the probability that both marbles will be yellow, and it says you replace it. So since it's a replacement, it's an independent, so it's just probability of A times by probability of B. So it's going to be what, 15 out of 37 times by 15 out of 37. That gets you what, 225 over 1369, which is about 0.164, so 16.4%. If you do not replace the marble, it's going to be, the first one's still 15 out of 37, but now with that second event, you're making the assumption that the first event was true, that you did choose a yellow. So what you're saying is 14 are left that are yellow, and there are only 36 in the bag. So 15 times 14 is 210, divided by 1332, which equals 0.158, which is 15.8%. So here it says your teacher passes around a box of 10 pencils, 8 pink pencils, and 13 green pencils. If you and two students in your group are the first to randomly select a pencil, what is the probability that all three of you select um, pink pencils? So again, this is a dependent event here because you're taking pencils out, you're not putting them back in. So um, the first one's the probability of you selecting a pink pencil. Well, there's 8 of them to start with, and then there's 10 plus 8 plus 13, which is 31. So the first person has an 8 and 31 chance of selecting it. Times it by, since it's dependent because there's no replacement, and you made the assumption that the first person already picked a pink pencil. So now there are only 7 pink pencils left, and there are 30 pencils total for that second person to pick. The third person makes the assumption that both the first two people selected pink pencils, so now there are only 6 pink pencils left, and there are 29 pencils total left. So it's going to be 8 times 7 times 6, which is 336, divided by 31 times 30 times 29, which is 26,970. Place that as a decimal, it's about 0.0125, or about a 1.25% chance of this occurring. All right, here it says, what is the probability that you and your group members choose a red pencil? So same idea. Now it's just red. There were 10 red pencils, so the first person has a 10 in 31 chance. Times it by the next person, making the assumption that the first person already selected a red pencil. That means there's 9 left and 30 pencils total. And then the third one has only 8 red pencils left because the first two were making the assumption that they already selected red pencils, and there are 29 to choose from. So the 26,970 remains the same, and but 9 times 10 times 8 should be what, 720, and that gets us 0.0267, so there's about 2.67% chance of that occurring. Okay. All right. So here it says you select 2 cards from a standard deck of 52 as probability that the first card is not a heart and the second card is a heart if you replace the first card before selecting the second, and it says you do not replace the first card. So with the replacement means it's an independent event. So probability of you not selecting a heart would be what, 39 out of 52. Selecting a heart would be 13 out of 52. So you just multiply those two fractions together and you would get something that's what, 3 over 16. 3 over 16 as a decimal would be what, 0.1875. So 18.75% chance of this happening. All right, so if you have this solution without the replacement, so the first one's still 39 out of 52, but now you have only 51 cards left, and but the top is still going to be a heart because you're making the assumption you already selected a not heart for the first one. So it's going to be 39 out of 52 times it by 13 out of 51, and this is going to be what, those terms, what, 13 out of 68. 13 divided by 68 is about 1.1911, or 19.11%. Okay. All right, so here it says for a fundraiser, a class sells 150 raffle tickets for a mall gift certificate and 200 raffle tickets for a booklet of movie passes. You buy 5 tickets for each prize. What is the probability that you win both prizes? So first off, it says The first event, there are how many possible outcomes? Well, there are 150 raffle tickets, so there are 150 possible outcomes. There were 200 movie booklets, so there are 200 possible outcomes in that event. You purchased 5 and 5, so the probability of you winning the mall certificates is 5 out of 150 or 1 out of 30. Probability of us winning the movie tickets is going to be 5 out of 200 or 1 out of 40. So the probability of winning both, they're both independent events, so it's just going to be the probability of the first times by the probability of the second, which is going to equal 1 out of 1200. So 1 out of 1200 is a small percentage. So 1 out of 1200, we'll leave it as. And that is being able to find probabilities of independent and dependent events. Hope this helps. Till next time.